Previously, we dealt with direct variation. We translated table of values and graphs into equations. We also answered some problems. Let us have a review of each before moving to the next lesson. First is the given table of values. This table of values models direct variation. So, what we need to do first is determine the constant k, which is the quotient of y, the quotient of dividing y to x. So we have y, 21 divided by 7 is equal to 3. 15 divided by 5 is equal to 3. 9 divided by 3 is equal to 3. And 3 divided by 1 is 3. So the constant k is 3. Then we write the equation of variation by simply substituting k in y equals kx. So we have now y is equal to 3x. Okay. Next, we have table graph. Okay. So all we have to do is still the same process as what we did in the table of values. So what we are going to do is identify one point on the graph. Okay, we have x, the coordinate is 4. We have y, 1. So k is equal to y over x. So our y is 1 and our x is 4. Even if you're going to make use of this point with coordinates 8 and 2, still the constant k is 1/4. You have 2 over 8 and that is 1/4. So we have our constant is 1/4. Okay. So we can now write the equation of variation as y is equal to 1/4 of x, or y is equal to x over 4. Okay? Let's have problem solving here. So what is the technique that I taught you? As you read, you solve. Okay? So d varies directly as x. We are going to translate this one into an equation. So we have d varies directly, that is equals k, as c. Then substitute the first given set of values. When d is equal to 12, copy k. Then c is equal to 4 because the second step in solving problem is determining the constant. Okay? Then we have divide both sides by 4 so we can determine the value of k. So we have 12 divided by 4 is equal to 3. Then we write the equation of variation by substituting k in the equation. D is equal to k is 3, copy c. Then we solve for c by substituting this in the equation. So we have find d. What is c? What is c? So what is c when d is equal to 18? So d is equal to 18. We have 3c, dividing both sides by 3. 18 divided by 3 is equal to 6. So the value of c is equal to 6 when d is equal to 18. Okay? Now, take note of the process because we'll be making use of this process in our next lesson, which is joint variation. With our learning target, I can solve problems involving joint variation. So what is a joint variation? How does it differ from direct variation? Joint variation is just like direct variation, but it involves more than two variables that are related directly. Now, as you can see, in direct variation, we only have two variables. Variables. We have one dependent variable in direct variation. Let me make use of another color. Okay. Indirect variation, okay, we have one dependent variable. Of course, the result must only be one. Then we also have one independent variable. In joint variation, we also have one dependent variable, but we could have two or more independent variables. Okay, that's how they differ from each other. The formula remains the same with the additional variables included in the product. Let's have some examples. The technique in solving problems involving joint variation is the same as that in direct variation. Suppose x varies jointly with y and the square root of z. So we are going to translate this one into an equation. Okay? So we have suppose x. Remember that the dependent variable is always mentioned first. Varies jointly equals k with y and the square root of z. Then, after that, we determine the value of k. So, we need to substitute the first set of given values. So, when x is equal to negative 18, copy k, y is equal to 2, and z is equal to 9. Do not forget to copy the square root sign. Then we have, simplify this one first. We have negative 18 is equal to k times 2. The square root of 9 is 3. So you have negative 18 is equal to 2 times 3 is 6 times k. So we have 6k. Divide both sides by 6 to get k. So we have k is equal to negative 3. Then after that, we get we write the equation of variation. We have x now is equal to, our k is negative 3. So we have negative 3 times y times the square root of z. We make use of this equation to solve for y when x equals 10 and z equals 4. So when x equals 10, substitute, copy negative 3, y is unknown, so just copy it, square root of z, and that is 4. Then we have, simplify this, 10 is equal to negative 3 times y times the square root of 4 is 2. So you have 10 is equal to negative 6y. Divide both sides by negative 6 so we can determine the value of y. So both numbers, both numerator and denominator are divisible by 2. So divide by 2. 10 divided by 2 is equal to 5. 6 divided by 2 is equal to 3. And then positive divided by negative is negative. So the value of y is negative 5/3. Okay, did you get it? Another example. Variable m varies jointly as the values of P and Q. Okay, this is step 1. Then step 2, solve for K. So we have M is equal to 88. When P equals 4, do not forget to copy K. When P equals 4 and Q is equal to 0.4. Okay? So we divide both sides by pwede tayo magdiretso students actually. Pero kung gusto niyo multiply muna, okay lang. So we have 4, 0.4 divided by 4 times 0.4. So we have 88. 88 divided by 4 divided by 0.4 is equal to 55. Let me check again. 88 divided by 4 equals, divided by 0.4 equals 55. So we have 55 is equal to K. Then after that, we go back to the equation M is equal to K, that is 55 PQ. Then lastly, we solve for the unknown M. Find M, just copy it. Copy 55. P is equal to 8 and Q is equal to 1.12. So M now is equal to 55 times 8 times 1.2 equals 528. Okay? Now, I want you to try this on a piece of paper. I think this is found in your book. If not, then just answer this. I'll be giving you 2 minutes to do this. Pause the video for a while, then play it again when done. Let's check it. Okay? Step 1, translate the statement of variation into an equation. if y varies directly as x and z, and y is equal to 90 when x is equal to 5 and z equals 6. So step 2 is determine the constant k. So we have divide both sides by 30 or 5 divided by 6. Okay? So we have k now is 90 divided by 30 is equal to 3. Okay? Then you write the equation of variation. So we have y is equal to 3 x z. So we have y is equal to, find y when x equals 4 and z equals 7. So we have 3 times x, that is 4. Then we have z is equal to 7. So we have y is equal to 12 times 7 is equal to 84. By the way, students, ha, pwede din sabihin na 30 to ha. Niretso ko lang para mas maiksi lang yung solution natin. Okay. Let's have another problem. Okay. Pause the video for a while and then try to solve it on your own for 2 minutes. And then after that, you play the video again. So let's solve it. So if we have y, step 1, write the equation of variation. We have y varies jointly as x and z. Then step 2, solve for the k by substituting the first set of values. And x is equal to 3, and x is equal to 3, and y is equal to 15, and z is equal to 6. So we have equals k. Okay? So hindi ko muna i-shortcut para makita nyo. So you have 3 times 6 is equal to 18k. Then we have equals 15. So we have divide both sides by 18. By 18. So our k is, both numbers are divisible by 3. So 15 divided by 3 is 5. And 18 divided by 3 equals 6. Then we go back to step 1 to write the equation of variation. So we have y is equal to, our constant is 5, 6. 5, 6 of xz. Then find y, okay, find y, copy 5 over 6, when x equals 8 and z equals 4. Okay? So we can multiply the numerators together. Now take note that all whole numbers have an understood denominator of 1. So we have 5 times 8 times 4 is equal to 160. Divided by 6. Divided by 6, we have 80 over 3 or 26.67. Okay, very easy. Let's have a real world problem. Same process will be done. The volume of a cone varies jointly as its height and the square of its radius. So what we are going to do is we are going to use the initial of the variables. Okay, height and radius. Volume V. Okay, so we have the volume V of a cone varies jointly as its height h and the square of its radius r. That's it. A cone with a radius of 6 inches, so we have 6 inches, r is being squared, so this must be squared also. And a height of 10 inches, so what's left here is k, has a volume of 120 pi cubic inches. So the step 1, step 2 is determine the constant k. So we have 120 pi is equal to 6 squared is 36. 36 times 10 is 360k. Dividing both sides by 360, so we will get k. So cancel this one, equals k. So we have 120 is divisible by by itself, and also 360 is divisible by itself. So 120 divided by 120 is pi. Then 360 divided by 120 is 3. Okay. So the constant is pi, my pi thirds. Then we go back to step 1 to write the equation of variation. So we have V is equal to our K is pi over 3 times H times R squared. Then find the volume. So we'll make use of this equation to solve for the unknown. Find the volume V, so just write V of a cone having, okay, having a radius of 15 inches. That's it. Then a height of 7 inches. Then we have pi thirds. Okay. So we have now the volume is equal to 15 squared. That is 15 squared is 225. 15 squared times 7 is equal to 1,575 pi over 3. Dividing it by 3, we have 525 pi, or to be exact, we have times pi, we have 1,649.34 cubic inches. Okay? So, I hope you are getting it correctly. So, it's time for you to answer activity number 8 on page 208 of your book. Okay? This will be passed in our passed or uploaded. Okay? I hope you understand our lesson for today. Okay? So, let's go back to our learning target. Reflect. Can I solve problems involving joint variation? If the answer is yes, then that's good. If the answer is no, then replay this video and answer the problems again. Okay, see you in our next class.